Okay, good afternoon. Now we are at the graphical method. Okay, so as I already told you, in graphical method there are two kinds of problem: maximization and minimization problems. Okay, so with the help of few examples we are going to study in detail the graphical method. Okay, suppose the given problem is like that only. Solve the following problem by using the graphical method. Okay, so this is suppose given problem. So what is problem? Maximization of z is equal to 3x1 plus 4x2. Okay, subjected to these are some given conditions or constraints. Okay, x1 plus 2x2 less than or equal to 4, 3x1 plus 2x2 is less than or equal to 6, x1 and x2 is greater than or equal to 0. Okay, suppose this is our given problem. Generally this problem is asked in university exam, minimum 10 to 12 marks. In some universities it is asked for 5 to 6 marks only. Okay, so to solve this problem, to avoid confusion, you should follow the procedure. Solve this procedure step by step, don't get confused. Okay, so this is maximization problem. So first step is what? We have to find out the coordinates of given condition. Okay, before that I'm going to tell you something about decision variable and objective function. Okay, so this is what? This is our objective function. Maximization of z is equal to 3x1 plus 4x2. Okay, this is what? This is our objective function, and x1 and x2, these are what? Our decision variables, and this less than or equal to, this is what? Our constraint. Okay, constraint is nothing but limits, as we are already discussed. Okay, and this x1 and x2 is greater than or equal to 0. Okay, the meaning of this is what? Our solution will be in the first quadrant. Okay, the meaning of this case is what? Our solution should be in the first quadrant. How? Suppose x1 and x2 are greater than 0 means what? x1 and x2 is positive value. Okay, greater than 0 is what? These are positive value, and as we know in the first quadrant both the variables are positive only. So that's what this represent the our solution should be in the first quadrant only. So what? First write the given constraints and change inequality signs with equal signs. Okay, just change this sign with equal sign. Okay, and there is very simple way to find out the coordinate. There is no need to make table or something. Just you can find out the coordinate by putting one decision variable is equal to 0. Okay, so what we have did, we just write down the condition as it is and changing the inequality sign with equal to sign. Okay, then what? We want to find the coordinate. So how to find the coordinate? Just put one variable is equal to 0 and find out the second variable. Suppose in first equation we putting x1 is equal to 0. Suppose we putting x1 is equal to 0, then we got what? x1 is equal to 0 and x2 is equal to what? 2. Okay, and suppose we putting x2 is equal to 0, then what? x2 is equal to 0 and x1 is equal to what? 4. Okay, this is our coordinate. Okay, how, sir? If some people having confusion, they can look at here. Okay, what is our first equation? x1 plus 2x2 is equal to 4. Okay, now we have to find out the coordinates. So to find out the coordinates, just we are putting one variable is equal to 0. Suppose we put x1 is equal to 0, then what happens? 0 plus 2x2 is equal to 4. Okay, and x2 is equal to 2. This 2 goes this side. Okay, x2 is equal to 2. Now our coordinates are what? 0 comma 2. Similarly, what? We put x2 is equal to 0. Okay, if we putting the x2 is equal to 0, then x1 plus 2 into 0 is equal to 4. Okay, what we get? x1 is equal to 4. Okay, and in what? x1 is equal to 4 and x2 is equal to 0. Okay, like that only we find out the coordinates of first equation. In similar way we have to find out the coordinates of the second equation. So how to find out the coordinates of second equation? Just put one decision variable is equal to 0. Suppose we putting x1 is equal to 0, then what we get? x1 is equal to 0, then x2 is equal to what? 3. Okay, if you put x2 is equal to 0, then what we get? x1 is equal to 2, right? Okay, so once we get the coordinate, then if you have the graph paper, then you can directly plot this coordinate on the graph paper. Suppose you don't have the graph paper, then you can draw the okay, once you find out the coordinates, okay, once you find out the coordinates, then we have to just plot these coordinates on the graph paper. Suppose you people having the graph paper, then please put this coordinate or mark this coordinate directly on the graph paper. But in some competitive exams, their graph should not be available. Graph may not be available. So in that case, what you have to do, just mark, draw this rough diagram and just mark the point with suitable scale only. Okay, in x-axis suppose we are putting one decision variable x1, and in y-axis we putting the second our decision variable x2. Okay, once we prepared this graph, okay, just mark these coordinates on the graph paper. What are these coordinates? 0, 2 and 4, 0 of equation 1. Okay, just mark this coordinate on the graph paper, 0, 2 and 4, 0. Okay, 0, 2 means what? x1 is equal to 0 and x2 is equal to 2. Okay, 4, 0 means what? x1 is equal to 4 and x2 is equal to 0. Okay, so 0, 2 means what? x1 is equal to 0 and x2 is equal to 2. Okay, so here is the point. And second coordinate is what? 4, 0. 4, 0 means what? x1 is equal to 4 and x2 is equal to 0. Okay, x1 is equal to 4 and x2 is equal to 0. Just simply mark the coordinate of equation number 1. Once we mark this coordinate, just join this coordinate with the help of line. Okay, directly draw on the line which passing through these two coordinates. Okay, just draw the line. Okay, after drawing one line, just numbering the line. Okay, this is what? Line 1 or line from the equation number 1. Okay, or line of equation number 1. Then just similarly mark the coordinate of second equation. Okay, what are the coordinates? 0, 3 and 2, 0. Okay, 0, 3 is here only. Here something. Okay, 0, 3. 0, 3. x1 is equal to 0. What is this? Is 0, 3. So how we can read it? 0, 3. x1 is equal to 0 and x2 is equal to 3. Okay, so x1 is equal to 0 and x2 is equal to 3. So here something. Okay, 0, 3. Now second coordinate is what? 2, 0. So means what? x1 is equal to 2 and x2 is equal to 0. So here something. Then just draw the line which passing through these two coordinate. Okay, and just join these two coordinates. Now again, once you draw the line, just number this line. Okay, just number the line 2. Okay, why 2? Because this line is drawn from the coordinates of equation number 2. Okay, this is what our the graph. Now the very important thing is what? Just what we have to do, we have to just marking the line or sketching the area. Okay, sketching the area. So what happened? Okay, now listen very carefully. Okay, most of the people did confusion here only. Okay, once we find out the coordinates and plotting the coordinates on the graph paper, the next step is what? You just check the constant of the given equation or given problem. Okay, suppose the constant is like that only. What is this constant? Less than or equal to. Okay, what is the constant of first equation? Less than or equal to. Okay, suppose the given constant is like that, less than or equal to, then mark the lines towards the origin. Where? Towards the origin. Then mark the line towards the origin. Okay, if the given constant is greater than or equal to, then mark the line away from the origin. Then mark the line away from the origin. Okay, now we are going to marking or sketching the given area. Okay, so please be clear in this constant. Okay, suppose the given constant is less than or equal to, then we have to mark the toward the origin. Okay, so what? Okay, so what? Our first line is here. Okay, and first line constant is what? Less than or equal to. Then what we have to do? We have to just mark the line towards the origin. Towards the origin. Where is the origin? Here is the origin. So we have to mark the line from the equation 1 or first line toward the origin. Sorry, this is first line. Okay, so toward the origin. So this is what our equation area we can say. Okay, just mark the line toward the origin from equation number 1 or line which is drawing from the equation number 1. Okay, similarly we have to check the constant of the second equation. What is the constant of the second equation? You can look at here, the constant of the second equation is also less than or equal to only. So from equation 2 or line 2 we can draw the, okay, so second equation is also less than or equal to. So what you have to do, just mark the line towards the origin. Similarly, okay, so from equation 2 we have to mark the line from the toward the origin, okay, from this line. Okay, once we marking the line or sketching the area, okay, now we have to find the feasible region. Okay, what we have to find the feasible region. So what is mean by feasible region? It is nothing but the just common region between the equations or between the line of equation. Okay, here is only two equation, that's why here is two lines only. Okay, so more the numbers of equation, then more the number of lines. So we have to just find out the common area between these two lines. Okay, this is what our common area. So many students will going to confuse between what is the common area. So to understand this we can go through very simple or basic example. Suppose there are 3 halls. In first hall the MBA students are there. Okay, in second hall there is engineering students. Okay, and in third hall suppose there is art students. Okay, so these are separate halls which containing the different stream students. Okay, so what we did now, in second hall we mixing some, or we allowing 2 to 3 MBA students and 2 to 3 some art students. Okay, now what happened in second hall, both three kinds of students are present, MBA, BE and BA. Okay, now this is what we can say, this is common hall. Okay, what in this hall all the all students from all the streams are present. Okay, like that only in this area the marking lines of the all the lines are present. Okay, here is what only lines of equation number 1 are present. There is no lines from the equation number 2. That's why this is what our common area, and the corner points of this common area will give us a optimal solution. Okay, what the corner points of this common region, and this common region is called as feasible region. Okay, nothing but feasible region. So we have the corner points, we know the corner points. Okay, what is the first corner point? 0, 0. Okay, this is first corner point. What is the second corner point? 0, 2. Okay, x1 is equal to 0, x2 is equal to 2. What is the third corner point? 2, 0. Okay, now what is this intersection point? Okay, how to find out the coordinates from the coordinates of this intersection point? Suppose if you draw this on the graph paper, then directly you get the coordinates. But if you are not drawing on the graph paper, then you have to find the coordinates. To find out these coordinates, just look at this equation. Okay, to find out the coordinate of intersection point, just follow the procedure. Okay, this is what suppose our given equation. Okay, to find out the coordinates point, this is what our given equation. Just solve these two equations. Okay, suppose I am subtracting equation number 2 from equation number 1, then 2x2 get cancelled, x1 minus 3x2 minus 2x1 minus 2. Okay, x1 is equal to what? 1. This minus get cancelled and 2 get cancelled. So here we got x1 is equal to 1. Just put this 1 in either one in one of the above equation. Okay, suppose I am putting this x1 is equal to 1 in equation number 1. You can put it also in the equation number 2. Okay, suppose I am putting this in the equation number 1. x1 is equal to 1 is put in the equation number 1. Okay, so here I got x1 is equal to 3 by 2, x2 is equal to 3 by 2. How? So 1 is subtracted from 4 and 2 go this side. Okay, so x2 is equal to 3 by 2. We can write 3 by 2 is equal to 1.5 also. Okay, so what is our intersection point? 1, 1.5. Okay, now what is the coordinates of this intersection point is 1, 1.5, or we can write 3 by 2, 1, 3 by 2. Okay, just now we have the 4 corner points. Okay, 1, 3 by 2. Okay, just put these corner points on the objective function. Okay, now what is our objective function? Now what is our objective function? This is what our objective function. Okay, maximization of z. So here we just writing maximization of z is equal to 3x1 plus 4x2. Okay, this is what our objective function, and we got some corner points or these points of feasible region. What is mean by feasible region? Feasible region is nothing but the common region of lines. Okay, so we got this 4 point. Just substitute this coordinate on the objective function and you will get the your required solution. So I am putting first coordinate 0, 0. So z max at 0, 0. Okay, x1 is equal to 0, x2 is equal to 0. If I am putting x1 is equal to 0, x2 is equal to 0, then what? Answer is 0. If I am z max at 0, 2, this is second point coordinate I am putting. Okay, what is 0, 2? X1 is equal to 0, x2 is equal to 2. Okay, if I am putting x1 is equal to 0 and x2 is equal to 2, we get 8. Okay, similarly if we are putting at z max at 2, 0. Okay, at 2, 0. So 3 into 2 plus 4 into 0. Okay, how? Just put this coordinate on the objective function. X1 is equal to 2, x2 is equal to 0. We got 6. Okay, and last coordinate is what? 1, 3/2. Just put 3 into 1. X1 is equal to 1 and x2 is equal to what? 3/2. 4 into 3/2. Okay, 3 into 1 plus 4 into 3/2 z max. So what we get? 3 plus 6 and answer is 9. Okay, z max is equal to 9. Okay, now we are finding the objective function at corner points. Okay, we got various solution. Okay, 0, 8, 9 and one is what? 6. Okay, we got this 4 solution at 4 corner point. Now simply look at the problem. What problem asking? Maximization of z means nothing but simple the maximum value among this. Okay, what is the maximum value among this? Is 9 only. Okay, so our required solution is what? Z max is equal to 9 at 1, 3/2. This is what our solution. When the problem is maximization, just finding out the maximum value among the corner points, and this is what your solution. If the problem is minimization, then just take care of constraint, the marking of line, and minimum value is what? Your answer. Okay, thank you so much.